Okay, so hi everyone. I think I'm audible to all of you. Yeah, so good morning, Artu Selvan, Gala, Raghavendra, everyone inside a chat. So yeah, good morning, good morning, good morning, everyone. Okay, Rishabh, Sri, good morning, everyone. And yeah, by the way, Happy New Year. So this is the very first class that we have for our full stack data science mastery. Pradeep, good morning. Yeah, good morning. So today we are going to start with the statistics. In my previous class, I was talking about basic of, or you can say introduction of pandas and numpy, so which we are going to use it inside our stats classes. And in this class, so obviously we are going to talk about statistics, and over there, so we are going to use pandas and numpy. So the concept that we have already discussed in our previous classes. And yeah, so this class is publicly live, so this class is live on YouTube just for today, so that we can just try to spread some sort of awareness among every one of us. Yeah, Sai, Teja, Teddy, Jayed, everyone, good morning. After so many days, sir. Yes, so in a new year 2025, so this is our very first class that I'm taking. Okay, so let me share my screen, guys, and let's start with the discussion. So I'm going to share my screen. Please let me know once you are able to see my screen. Thiaga, good morning, good afternoon. Okay, so fine, my screen is visible and I'm audible to all of you. So let's get started with a live class now. So, like I said, so today we are going to talk about statistics, and I have already discussed about pandas and numpy. Introduction, just a basic I have discussed, so that we will be able to perform some sort of a basic operation. So when I'm going to show you some example with respect to statistics. Pavan, happy new year. Yes, happy new year, Pavan. Screen is visible, Rishabh is saying. Okay, so let's get started with the basic of statistics, guys. So what and all terms and a keyword or buzzword generally we try to use with respect to statistics, that is something which I'm going to discuss in this particular class. And if you have any kind of a doubt, please let me know. I'll be happy to clarify all of your doubt. Okay, so now we can start. So basically a statistics, inside a statistics, we talk about two term frequently. So the very first term is population, and the second term is sample. So what is the meaning of this population and what is the meaning of sample? So see, guys, in our statistics, so generally we talk about a data set, and we talk about a data set with respect to a particular context or with respect to a particular problem statement that we are trying to solve. For example, uh, maybe I can ask you a question that try to find out that how many people is having a programming proficiency in your college. So what you will do in that case, you will go to your college, you will go to each and every classes, and then maybe you will try to ask a couple of questions, that how good you are with respect to a particular coding language, how good you are with respect to solving a competitive programming, how good you are in terms of solving some sort of a DSA problem or maybe a project. And based on that analysis, so you are going to prepare your report. Now, so when we talk about this analysis, when we talk about this reporting part, so obviously you are, there is a possibility that you will go to each and every student inside your college or maybe inside your community, and you are going to ask a question, and based on that you are going to build your analogy. Now, there is another possibility that you will not go to each and every one, but you will go to a couple of people, maybe just a bunch of people, a near and dear one, and you are going to ask the same question. Now, what is the difference between these two? So, in a first scenario, so when you are going out and you are asking a question to everyone, and based on that, you are trying to build your report or collect your data. In that situation, it's actually called as population because you are considering each and everyone. Now, if I'll talk about a second situation, in that you are just going to ask the same question to a couple of people, now that is something called as sample. So whenever we talk about statistics, whenever we are talking about a data collection, whenever we are talking about building some sort of analytics on top of the data, so sometime you will end up doing things with respect to a complete data set or with the complete population, and sometime you will not be able to access the whole population, but you will be having an access of some sample of the data, and based on that you are going to give your conclusion. So this is where population and samples comes into a picture, because stats means all about the data set. Again, so many government organizations, so they try to run a lot of surveys. For example, so how many people are below poverty line in a particular state, how many uh, people are above a literacy rate, average literacy rate, or government even try to perform some sort of a survey saying that how many people is able to access a healthcare services, how many people are not able to access a healthcare services, and based on that they try to make a policies, they try to take a decision, and so many things happens just based out of the survey or just based out of the data collection. So if in a situation where you are able to reach out to each and everyone, so that in that situation we can say that yes, you are collecting a data from an entire population. And in some of the situation, I would say that in a real time, in most of the situation you will not be able to access the entire population, you will not be able to collect a data set from each and everyone. And this is where sample comes into a picture. Now sample is not going to give you a accurate result in most of the situation, but if you are going ahead with the population, so population sample may give you a biased result, but population is always going to give you a true result that you are looking for, and based on that you can try to build up policies, you can try to derive the entire analytics on top of the data, and you can try to build even a model going forward. Now, so this is the difference between population and a sample, right? Now, inside this inside this population or sample, you will be able to find out, based on the characteristic of the data, you will be able to find out two kind of a data majorly. So one is basically called as qualitative data, and another one is called as basically a quantitative data. So one is basically a qualitative data, qualitative and quantitative. So what is the meaning of this qualitative and quantitative? So basically these are called as variables. So there are two kind of variable you will be able to find out inside a data set. So one is a qualitative, and in other word it's called as categorical data. Categorical, and in this case it is basically called as numerical data. So when we talk about a categorical data, what is the meaning of it? So let's suppose if we are talking about male and female, if we are talking about a gender, if we are talking about yes or no, so here we are trying to divide entire population or entire sample into a categories basically. So if I'm going to ask you a question that how many males and females are there inside your college, so again based on the population or based on the sample, so you are going to tell me that okay, this is the number of the male, this is the number of the female, this is the percentage of the male, and this is the percentage of the female who is attending a college. Again, similar kind of things are applied everywhere across each and every kind of a data that you are going to collect or a statistical operation that you are going to perform. So qualitative means categorical data. So whenever we are talking about a categories, yes, no, male, female kind of a things, so in that case it's called as categorical. Now, if I'll talk about a quantitative data, so again, you can try to derive it in terms of a number. So if I'm going to ask you, what is the average age of a person inside this particular class? Or what is a average percentile that you all have achieved in your graduation? So again, that is basically a quantitative data. So where you are trying to quantify it with respect to a number, and based on that, you are going to tell me something. Now here, so if I'll talk about a quantitative data, so again, there is something called as discrete. So again, you can try to redefine this quantitative data into two way. So one is a discrete, and the another one you can say as a continuous data. Now, what is the meaning of this discrete data? So if I'm going to ask you a question, that how many number of people are there inside your college, or how many number of faculties are there inside your college, or how many number of male and females are there inside your college, or maybe inside this class itself. So you are going to tell me in a exact number that there are 10 faculty, or maybe there are 50 number of male, 50 number of female, something like that. And maybe if I'm going to ask you that how many children do you have, if you are married and if you have a children, so how many children do you have? So obviously you are going to give me the absolute number, a countable value, you are going to give it to me, and that comes under a discrete data. Now if I'll talk about a continuous data, so if I'm going to ask you a question, that what is your height, what is your weight? So maybe you are going to tell me that your height is 5.9, 6.3, your weight is maybe 70.3, or maybe 80.2. So that kind of a data where we have a fractions attached with it, so that is something called as continuous data. So again, we have a population, we have a sample under which we can try to define this like a variables inside this population or sample in a qualitative way, in a quantitative way. And again, if I'll talk about a quantitative data, so there could be a discrete data, absolute number, and there can be a continuous data, so data with a fraction, so maybe like a weight, or maybe a height, something like that, or maybe even a age, that my age is 32.3. So that is again a continuous kind of a data that you will be able to find out. Now, so this is just a variable. Generally, we try to use inside population and a sample, and it's always better. So when we talk about a statistical analysis, it's always better to gather a population data instead of gathering a sample data, because, like I said, sample data is not going to give you always a correct result, but yes, population data is always going to give you a correct result in any kind of a situation. Now, that's completely fine, but beyond that, right? Beyond that, there are another parameter or another buzzword that you will be able to uh, come across, is something called as parameter and statistics. Now, what is this parameter? What is this statistics? So here you will be able to understand the real meaning of an statistics. So here I'm just trying to explain you that what should be a definition of an statistics as per the data that you are going to collect, or data that you are going to gather, or data that you are going to analyze. So if I'll talk about a parameter, so a summary measure for an entire population is called as a parameter. For example, if I'm going to ask you a question that what is an average age, what is an average age of a student who is attending this particular full stack data science class? So if I'm going to collect a data from every one of you, not just from a sample, not just from 5 or 6 people, but from everyone, if I'm going to collect a data, and if I'm going to define an average based on the collection of a data from every one of you, everyone means 100% of you, now that will become basically a parameter. So parameter, definition wise, a summary of measure for a population is called as parameter. So generally, we try to define the parameter based on the large amount of the data. We try to parameterize a lot of things, right? That what will be the average temperature in this particular location. So again, we try to collect years and years of data, and based on that, we try to do this kind of a analysis. What is the average age of a person to go into a college, or maybe go into a 10th standard, or maybe into a 12th standard, or to appear for a IIT exam, NEET exam, or any other kind of a exams. So over there, we try to always consider a big chunk of the data, which is technically a population of the data, and based on that, we try to define that particular number, and that particular number becomes a parameter. So whenever you are trying to take out a summary on a whole population, entire population, then only you can claim that it became a parameter. Whereas if I'll talk about statistics, so in that case, whenever you are trying to perform the same kind of a measure, but not on all the data, but on a small size of the data or chunk of the data, so that become statistics. So in statistics, because it's very hard in most of the situation, in most of the cases, it's very hard to get the population data, to get the whole data that we are looking for. For example, so let's suppose if I'm going to ask you a question that how many people is been vaccinated for a polio in your society. So again, to collect that particular data, you have to go to each and every person and then ask a question that whether you have taken a polio drop or you have not taken a polio drop. And that is going to be very, very difficult task. That is going to be a very, very tedious task for any organization or any individual. For individual, obviously it's not possible. So organization try to perform this kind of a statistical analysis, and it's very, very difficult. And even government is having a like a lots of statistical establishment, and based on that, government try to create a lot of different kind of policies. So maybe for underprivileged people, for middle class people, when for a rich people, so when government try to take any kind of a decision, so obviously they need a backup of the data, and based on that backup of the data, so they try to take any kind of a decision in a favor of people or maybe against it, depends based on the government and country to country, right? So like I said, it's very difficult to collect a data from the entire population. So is most of the situation, what any organization does is, so they try to collect a sample of a data, and based on that, they try to build the analogy. They try to derive the entire result with a error margin, and then they try to make a policies. So whenever you are not having an access of the entire data, but you are trying to build some sort of a measurement, that is called as statistics. And in the entire statistics, right, in the entire statistics, we try to learn about that how, even if I don't have an access of whole amount of the data, but still if I have to make a decision at one point of a time, how I will be able to make it simple, right? Because like I said, in most of the cases, you will not be having an access of the entire population. So here, if I'll talk about the actual definition of a statistics, so it's basically a summary of measure measure based on a sample. Sample means not the whole data, a chunk of the data. Like I said, so if I'm going to ask you a question that go outside, go inside your college, go inside your community, go inside your hostel, go inside your city, and then try to find out that how many people are good with a coding, or good with a programming, or maybe good with the AI. So you will not be able to reach out to everyone. So what you will do is, maybe you will try to reach out to the people in a packets, and then you are going to perform some sort of a mathematical calculation that, okay, I have reached out to these many people said yes, these many people said no, so this could be the average. But again, that there is a possibility that that particular average that you are trying to tell me, that this is the percentage of the people, or average, on an average these many number of people, or maybe out of 10 these many number of people are actually very active, or they are aware about basically a coding, programming, or maybe a AI. So you will not be able to reach out to everyone. So what you will do, you will just go to the sample of the people and collect the data, and based on that you are going to build your analogy, and this is actually called as statistics. So hope all of you are able to understand what is the actual meaning of a statistics and how we are going to define it. So here we have discussed couple of terms. One is a population, one is a sample. I believe you all are able to understand. Then there are the variable called as qualitative, quantitative. Inside quantitative there is something called as discrete, there is something called as continuous, and then there are two more terms called as parameter and statistics. Parameter means, so something will become a parameter once you are able to access the complete population data in whatever category you are doing a survey or you are trying to build up the data. And statistics means when you are trying to build up something on top of just a sample data, that will become an statistics. Making sense, guys, to all of you? Yes. Can somebody share the link? Okay, link for what? I'm not able to understand. How can I join the live session? So I think you are already inside a live session, by the way. Yes? Okay. So Raghavendra is saying quantitative measured numerically and qualitative is nothing but a numerical, nominal data or categorical data. Yes, that's true. That's true, Raghavendra. Yeah. Okay, so I believe all of you are able to understand all of these terms. Don't worry, no one is going to ask you this particular term. This is something that you are going to use in your interview, even for a normal discussion. So face to face discussion, you are all are going to use this particular term. And again, you are not supposed to by heart any of these terms. By the time we are going to complete our machine learning classes, you will be well versed with all of these terms. Believe me, you all will be aware about each and every term that I'm discussing over here in a well manner. Fine. Now, moving next. Moving next over here. So if I'll talk about statistics, now coming to the statistics, because as we have to go through the entire statistical part, so let's try to explore a little bit of statistics. So one by one, we are going to derive each and everything, whatever is necessary. So this is what we have done so far. So now let's try to understand what kind of a statistics we are going to learn, what kind of a things which exist inside the statistics. Again, inside statistics there are a certain categories that we are going to learn, we are going to explore. So there is something called as statistics wise. If you are going to ask me a question that what is a type of statistics, so the very first kind of a statistics that we are going to learn today, so in today's class we are going to explore a statistics which is called as descriptive statistics, and then there is a statistics called as inferential statistics. So there are again two kind of a statistics that we are going to explore: descriptive stats, and the second one that we are going to explore is inferential stats. Now, so let's talk about a very first part. What is the meaning of this descriptive statistics and what and all things comes under this descriptive statistics? And then we'll come to the inferential statistics, and then we'll try to explore what and all things which comes under inferential statistics. With the example, obviously, I'm going to explain you each and everything. Plus, we'll try to bring some of the practical stuff as well in between these two. Okay, because at the end of the day, so whatever library that we have discussed, whether it's a pandas, whether it's a numpy, so we are supposed to use it to do some sort of a calculation and to do some sort of analysis on top of the data set. Maybe not today, maybe tomorrow, but yeah, this is how we are going to approach to all of these things one by one, one by one. So let's talk about a very first part, which is nothing but descriptive stats. Now, what is this descriptive statistics, by the way? What and all things comes into a picture? So, descriptive statistics is all about summarizing and describing. Simple. So, descriptive statistics, as its name suggests, just try to focus on couple of words over here. So, couple of letters over here. So, descriptive statistics is nothing but a kind of a statistics which has been used to summarize and describe the characteristic of the data set using a measure of central tendency and a dispersion. So now again, I'm introducing a new buzzword over here. So which is called as measure of central tendency and a dispersion. Now, what is this measure of central tendency and dispersion? Now, what is the meaning of this? So, what is the meaning of measure of central tendency? So, I believe, and I'm assuming that at least most of us, or almost 100% of us, 100% of my population. So, population means a person who has joined my class. So, almost 100% of my population are aware about a measure of central tendency, but maybe they are not familiar with this particular word, and because of that, so I have to repeat it inside my class. But yes, I firmly believe that most of us, most of my students are already aware about it. And all of you have gone through this measure of central tendency in your 8th, ninth, 10th, 11th, and 12th. Everywhere, everywhere. And even in your day to day life. So you must be aware about this particular word, which I'm going to take under measure of central tendency. So, anyone, guys, anyone who is aware about a measure of central tendency? Yeah. So again, this word is new, but the term which comes under this particular word, under this umbrella, so that is not going to be new for any one of us. Believe me, all of you are aware about it. And that too, it's one of the simplest one of the basic one that you will come across. So here, so whenever we are talking about a measure of central tendency, let's talk about just first one. So the very first one is measure of central tendency. Now, inside this, if I'll talk about a measure of center tendency, so inside this, there are three terms comes into a picture. One is a mean, second one is a median, and the third one is mode. And I believe all of you are aware about, at least you all are aware about a word, right, guys? Everyone? Yep. So under measure of central tendency, I'm not talking about dispersion as of now, I'll talk about it in later stage, but yeah, so under a measure of central tendency, all of us are aware about mean, median, and a mode. Now, just to do a recap, let's talk about a mean, median, mode one by one by one. So here, mean is nothing but average, I would say. Right. What is mean? So mean is nothing but an average. So let's suppose I have a data 1 comma 4 comma 5 comma 2. Now, if I'm going to ask you a question, that what is a mean? What is a mean of this particular data? Let's suppose you have collected this particular sample, right? I'm talking about just a sample over here. So I have collected this particular sample. Now, what is a mean of this particular sample? What is the average of this particular sample? So it's nothing but summation of all the data, and that is going to be a mean. Simple, right? Summation of all the data divided by number of data is going to be the mean. So 4 plus 1 5, 5 plus 5 is equal to 10, plus 2 is equals to 12, and 12 divided by 4 is equals to 3. So the average of this particular data set which has been given over here is nothing but 3, right? So mean is going to be 3 at any point of a time. Okay, fine. So mean is nothing but, and nothing fancy. So mean is just a 3. So again, we keep on asking question, right? So what is the average age of a people in this particular society? What is the average age of the people in a college? What is the average salary of a person for this particular position? Generally, we ask this kind of a question even over a social media. So just right before your class, so I was taking a full stack data science Hindi batches, and over there we were discussing about actually a salary. And some people said that yes, their college, right? So their college tried to showcase a 10 LPA of package, but the average salary was technically 3 LPA, right? So they never talk about an average, they always talk about which one, the outlier one, so which is not even close to the average. But yeah, so we try to talk about this average lot of time. So what and all, like generally we say that, right, like what is the average cost of living in a particular city? So maybe in a Bangalore, Delhi, Noida, New York, Mexico, or anywhere else. So we talk about this particular term very very frequently even in our day to day life, and that is something called as mean, and that comes under a measure of central tendency, this one. Then the second term, right? Then the second term is basically a median. Second term is basically a median. So now if I have a data, let's suppose a same data, so 1, 4, 5, 2. Now what is a median, guys, by the way, definition wise? So we have 1, 4, 5, 2. Okay, let's suppose I'm going to add one more data. So I'm going to add basically 3 over here. So what is median, by the way? So can I say median is nothing but a middle data? True or false, guys? See, this is the data set which I have given to you, right? Now I'm asking you a question that what is a median of this data? So can I say definition wise in a layman way that median is nothing but a middle of the data? Yeah, Raghavendra is saying median is a middle value. Okay, Hitesh is saying we use median when we have outlier. Okay, so everyone, Teddy is saying 5, Raghavendra is saying 5, Sri is saying 4. Okay, now Sri is saying 3. Okay, so any other guess, guys? What will be the median of this data, the data that you are able to see? Yeah, what is the median? Can I say median is going to be 5, by the way? Can I make this statement? Is it correct? Yeah, it's correct, right? Yeah. Okay. So people who said that median is going to be 5, it's not correct, by the way. See, median is not just a middle data. So definition wise, yes, median is nothing but a middle of the data. But after ordering it, after sorting it, so first of all, you have to sort, and then whatever data will come in the middle, that is actually going to be your median. So, okay, if I'm going to sort it, so it's going to be like 1 and then 2 and then 3 and then 4 and then 5. Now, what is a middle data? So we have 3. So the actual median is going to be 3 for this particular data. Fine. So median is nothing but a middle data, but after ordering. Simple definition wise, median is nothing but after ordering middle of the data. Now let's suppose I have an even data. Let's suppose I'm going to strike off this 3. I have just this data, right? I have just this data. So for this data, what is going to be the median? Because this is the even data. So here, 1, 2, 4, and 5, right? This is the data in an order fashion. So if I have an even number, so in that case, I'm going to consider a middle 2 data, and then I'm going to take out the average. So 4 plus 2, basically 6. 6 divided by 2 is equals to 3. So in this case, median is equals to 3. Even in this case, median is equals to 3. Simple, right? So in case of a even data, this is how we are going to find out the median. And in case of basically like a odd data, it's very easy peasy to find out the median. Now, what is a meaning of median, guys? Anyone? So what actually median defines? Average, yes, we are able to find out. But with respect to any context, if you can give me like what is the meaning of median, by the way? Yes? Anyone who can tell me, so like by taking some of the example that, okay, fine, here I'm going to use a median. Yes. So where we are going to use a median in general. See, definition wise, finding out a median is not a difficult task at all. Anyone and everyone can find out. Any kids can find out this one. But why we are going to use a median? Mean, I'm going to take a lot of examples, and you will be able to see that most of the cases we are using mean. But what about median? So Sri is saying height among the student. Raghavendra is saying when we have outlier in a data, we use median in a particular column. Yes, so Raghavendra is correct, and this is one of the example of where we are going to use a median. So for example, I have a data set. I'm going to take some small data. So I have a data set. I'm going to take it even in ascending order. So I have a data set 1, 2, and then 5, and then 6, and then 8, and then we have basically 80. Now, what is a median of this data? Median of this data is basically 5, right? Median of this data is 5. But can I say that we have somewhere a kind of a skewed data, right? We have somewhere a kind of a skewed data, so which is very, very far from a median, I would say, on one side. So whenever we have to find out the skewness into a data, whenever we have to find out the alignment of the data on right side or maybe on a left side. So going forward, I'm going to discuss about what is the meaning of a left skewness, what is the meaning of a right skewness. Again, these are the two terms which I'm going to discuss with the example and with the graph as well. So here, can I say that with the help of median, I will be able to find out how median of its data is basically 5. It's not 5. Basically, we have an even data, right? So 6 plus 5 divided by 2. It's going to be 5.5, by the way. Yeah, I'm just assuming over here. Yeah, so Raghavendra has already answered, but yeah, I'm just assuming over here. But technical way, so it's 5 plus 6 divided by 2, which is going to be 5.5. Very simple, right? 5.5. So I think we have this kind of understanding so that I don't have to go with the exact number. So I'm just trying to like build a context over here that here we have a big outlier which is very, very far from my median, which is 5.5 over here, right? Which is 5.5 over here to be very precise. So we have some sort of a skewness into our data on one side, maybe a right, maybe a left. So whenever we are going to talk about right skewness or left skewness, then I'll be talking about the entire derivative of it. But yeah, we have somewhere this skewness inside our data, and this is where median comes into a picture at the end of the day. Okay, that's completely fine. Now, so where we are going to use a median. So let's try to talk about a use case. So here, the use case wise, in case of descriptive statistics, right? In case of a descriptive statistics, so summarize the central tendency of the data. So as of now, I have already listed down over here. So there is something called as descriptive statistics and there is something called as inferential statistics, right? As of now, we are talking about descriptive statistics, under which we are talking about median, mean, and mode. So now inside a descriptive statistics, to summarize a central tendency of a data set, to find out a skewness into a data set, so we try to use a median in general. So basically summarize, I can make a statement over here that to summarize the central tendency of data, CDT. So I'm going to just write CDT over here, summarize the CDT, central tendency of the data. Generally, we try to use basically a median. If I'll talk about a second use case, right? So second use case. So here, let's talk about real estate, right? So median is going to define basically, let's suppose if I'm going to buy a house in a particular area, and someone is selling a house in a very, very high price, and maybe someone is selling a house in a very, very low price, but a median of the house price is very like the very high and the very low is very far from the actual median of the data, then obviously I'll go and I'll ask the question that, okay, so there is some problem, or maybe there is something very, very good. So if price is very, very low, means there is some problem with a particular property, with the particular real estate value, because there is a possibility that there is a litigation which is going on. And if property price is very, very high in a particular area, then again there is a problem, right? Again there is a problem. So we'll go and we'll try to figure out that what I will be able to get in that particular area if per square feet price of the property is very, very high. So in this way, again, we are trying to detect the outlier, based on the outlier, based on the skewness. So at the end of the day, it's just a skewness that we are trying to calculate, and based on that calculation, so we are trying to make certain decisions. So again, inside the real estate, we do the same thing. Now, Even in education, so in terms of a score that we try to obtain, right? So again, to summarize the student performance, to summarize a class performance, to summarize a outlier maybe on a low side or maybe on a high side, so we try to use a median. So anywhere wherever we have to find out a central tendency of a data set, so wherever we have to summarize the central tendency of the data set, whether it's a real estate, whether it's a education, whether it's a income distribution. So in India itself, so 1% people holds a lots of wealth as compared to 99%, right? So these 1% are technically very, very far from a median of a total average income of a people in our country. So we keep on getting this kind of a news, and there are people who keep on doing this kind of analysis that okay, so only this much percent of the people is holding this much number of wealth, so maybe the wealth distribution across a people is not equivalent or not equal. Again, same thing happens with respect to education, same thing happens with the healthcare, same thing happens with real estate, and everywhere you will be able to find out this. Now, so what is the advantages? What is the advantage of using this median in general? So median is not affected by an outlier. So whenever you are talking about a median, the beautiful part about a median is doesn't matter how many outliers I have. Let's suppose I have a 80, then I have a 9, I have maybe a 18, I have 2, I have 1, and then I have maybe 1,000 over here. So if you are going to find out a median of this entire data now, this entire data, which I have listed down 1, 2, 5, 6, 8, 89, 18, 2, 1, and 1000, right? So here your outlier, I know this is the outlier, but let's suppose I'm talking about a billions of record. Now in a billions of record, just by looking into a data, you will not be able to tell me. So obviously you have to find out the median, right? So maybe you can try to use a NumPy package or maybe Pandas package, and maybe you can try to find out the median in a multiple column, maybe into a one single column, one single record. So here, whenever you are going to find out a median, whatever is going to be a median, it is not going to get affected or influenced by, I would say, the outlier that you will be having. Can I make a statement, guys? That median will never be influenced by the outliers, and that's the advantage of using a median. So whenever we are trying to measure a central tendency, so this is the advantage every time you will be able to get, because outliers, maybe it's a low side or a high side, it is not going to affect your median. Your median is going to be intact. The second advantage is very obvious, so easy to calculate, right? Easy to like perform some sort of a small analytics on top of the data and to understand little bit about it. I'm not saying that this median is going to give you the whole picture about the data. No, never. It is not going to give you. Otherwise, we would have just studied about the median and we don't have to go ahead with the entire stat syllabus, right? But yeah, median is not going to give you the conclusive result, but still it's good for a first hand analysis, I would say. Now, it always try to represent a central point of the data. So if I'll talk about a median, it always try to represent a central point of the data. That is again another advantage that you will be able to get. Now, disadvantages, so again it is having advantages. Now if I'll talk about a disadvantages, so median is not suitable for a data set where data set is repeating itself. For example, right, for example, so I have one, then one, I have two, I have three, I have three, again I have two, I have four, I have five, I have one, I have two, I have two, I have three, I have five. So for this kind of a data set, median is going to be useless. Median is not going to give you a conclusive result at all. So wherever data is repeating itself, so you will be able to find out a lot of data set during our studies that it is repeating itself. So again, if you're going to find out a median, it is not going to give you any kind of a conclusive result. It is not going to tell you anything. Now, the another disadvantage of a median is, so it always ignores median. So if I'll talk about median, so median always try to ignore the actual value of a data point beyond their order. Because see, median is what? Order the data, find the middle value. That is a median, right? And maybe my actual data lies on this side. Maybe my actual data lies on this side. So it will not be able to give me any kind of a conclusive result or outcome about my actual data. It is just going to give me some middle values and done, right? So this is again another disadvantage that you all will be able to find out with respect to mean, median, and mode. But the whole idea behind this discussion was to revise the concept that we have studied in our childhood. So now I believe we are able to revise it in a best possible way. So what is the meaning of a mean? What is the meaning of a median? Now going back to the next one, right? Now going back to the next one. Now if I'll talk about a mean, so median is not highly sensitive, I would say. But if I'll talk about a mean, mean is highly sensitive and it may get influenced a lot by an outlier. For example, so I have 3, right? I have 3 as an average for this data. Now let's suppose I have an outlier 100 over here. So as of now 3. Now if I have 100 over here, then 100, so it is going to be 112 divided by 1 2 3 4 5. So 5 is equals to how much, like 22.4. So just imagine, so I have just added one single outlier, and when I'm trying to find out a mean, I'm trying to find out the average. So when I have not added the outlier, it was 3. And when I have just added one single outlier over here, one single outlier, and see the range. So mean is highly sensitive. Whereas if I'll talk about median, if you're going to find out a median, still this is going to give you some middle values. Yes, it is going to give you a middle values. Now people are asking that what is outlier, because I haven't discussed about outlier so far. Now as its name suggests, and I will be talking about this term again and again and again so many times, and in with Python, believe me, with every data set that you are going to pick and choose, with every data set, we are going to find out an outlier in every EDA operation before sending my data for a model building or for a model training. Fine. So outlier is nothing but, let me, like, as you have asked me a question in a chat. So outlier is nothing but a kind of a data which is very, very far from your normal trend, from your normal range of the data. So here, all of this data set is ranging between 1 to 5, right? All of this data set is ranging between 1 to 5. And there is another data which I have added, which is 100, which is very, very far from this particular range. So this is something called as outlier. Now, in your class, let's suppose I'm going to give you example. So on an average, people are able to score 70%. Let's suppose people are able to score 70% in the exam. But there is a person who is able to score 99.9% in the exam. So can I say that that 99 percentile is going to be the outlier? Yeah, that 99 percentile is going to be the outlier. Again, so let's suppose on an average, people are scoring 95%, and there is a person who has scored just 2%. So again, that 2% person is basically going to be the outlier. So again, depends upon the context and situation. So a kind of a data, definition wise, if I'll say outlier, so a kind of a data which is very, very far from a norms, maybe on a left hand side, maybe on a right hand side, that is called as outlier. Very simple, right? Very simple. So in every data set, by default, you are going to perform this ADA operation, and by default, you are going to find out the outlier. And there are many statistical term which is going to help you out, and this is something that we are trying to study as of now, right? Okay, so fine, mean is fine, median is fine. Mean is very much sensitive towards our outlier, median is not at all sensitive towards our outlier. This is something that we are able to conclude, right? Now mean is generally been used with the symmetrical data distribution. So where data is distributed symmetrically means equally data is distributed across the entire data set, then we can try to use a mean. Otherwise, if data is skewed means negatively skewed, or maybe like a left is skewed or right is skewed, in that case, if you are going to use a mean to perform some sort of a statistical analysis, I would say it's of no use. Literally, it's of no use at any point of a time. Now, moving ahead, now the third term which I have written over here. So what was that? The third term was basically a mode under measure of central tendency. This is the third term. Okay, fine. So let's talk about a third term, guys, which is technically a mode. So what is mode, by the way? I think we all know the definition of mode. What is mode? Yes, in a chat, guys. In a class, please chat. So Raghavendra is saying mode is used for the categorical data. Okay, mode is the value appears most frequently. Jayad is saying that mode is a value appears more frequently. Yes, Jayad, that's correct. So mode is nothing but a kind of a value which appears more frequently into a data, and that is something called as basically mode. So number of repeating, not it's not a number of repeating, it's basically a data. So we are talking about basically a data set. So the kind of a data set which is repeating itself again and again and again, that is technically called as mode. So here, if I'm going to write maybe a couple of things, so 1 comma 1 comma 1 comma 2 comma 3 comma 2 comma 1 comma 1 comma 1 comma 5. So can I say that one is appearing most frequently inside the data? Yeah, one is appearing most frequently inside the data. So whatever data that I have taken as of now, so more one is appearing most frequently inside the data. So can I say that that mode for this data is going to be one? Can I make this statement, guys? Yes. Yeah. Now, so I have another data. So maybe 1, 2, 5, 6, 8. So 5, 6, 8. Sorry, it is converting into a shape. 1, 2, 5, 6, and 8. Yeah. So what is the mode of this data, guys? What is the mode of this data, by the way? Yep. What is the mode of this data? 1, 2, 5, 6, 8. What is the mode of this data? Okay, Teddy is saying no mode. Sri is saying no mode. Joy is saying nothing. Yes. So it's not like every this is the reason I'm discussing about this example. So it's not like every time you will be able to find out mode inside a data. So if there is no repeating data inside a data set that you have, in that case there is no mode at all. Now, so there is something called as unimode. So if you have one repeating data, there is something called as bimodal. So where you have two repeating data, there is something called as multimodal, where you have more than two repeating data set. Simple. So there could be a no mode, there could be a unimode, there could be a bimodal, and there could be a multimodal. So even these kind of a mode exist terminology wise. Again, you are not supposed to remember any of this terminology. I never suggest anyone to remember these kind of a terminology. You will get used to it. So eventually you will get used to it at the end of the day. Okay, fine. Mode is completely fine. We will be able to find out the mode if there is a mode, and obviously we will not be able to get any kind of a mode if there is no repeating data at all, because mode is all about at the end of the day repetition of the data set. Fine. Okay. Now, so what is the advantage of this mode? So you can try to apply this mode to calculate a frequency of the data set, even with the numerical data and even with the categorical data. You will be able to find out, right? So this is not possible with the other other term that we have discussed. But yeah, with respect to a mode, you will be able to find out a mode with, because it's all about just a repetition, right? Now, so mode is something which is again not getting affected by any kind of a outliers, means any kind of a very high values or extreme values, I would say. So that is the advantages that all of you will be able to get it. Now, so if I'll talk about an application, so just talk about a little bit of application of the mode. So application wise, so yes, this mode can be used to find out a most common category among a lot of things. right? For example, so nowadays Swiggy, Zomato, Blinkit, all of these things are very much popular. So obviously they try to find out that what is a most selling categories. So whether they are able, let's suppose I'm talking about a Blinkit, right? So people used to order groceries, people try to order maybe fruits or maybe a vegetable, maybe their kitchen items. Nowadays they have also listed down some of the clothing items over there. So obviously they try to focus more and more on that particular category which is a highest selling one. So maybe they can try to select a first 10 categories. They will try to enhance that particular services as much as possible so that they will be able to generate more and more kind of a revenue. Again, same thing is with the Ola Uber. So in Ola Uber, they have a luxury car, they have like a very very economical car as well in their like a fleet. And again, so they are going to deploy all of those cars, they are going to assist all of those categories based on obviously a frequency of the use. That again on Monday, so maybe people mostly try to travel from office to home, home to office, and back and forth. So maybe I'll try to deploy more of a economical cab in that is a category, right? That is one of the categories. So economical cab in that particular path or in that particular route. Maybe on a weekend, right, people prefer to go outside to pub, to bar, to enjoy, to party. So maybe I'll try to deploy some of the luxurious car over there, because maybe there is a very high chance that people are going to book that particular car on that particular day. So again, everyone try to do a lot of categorical analysis, that which category is performing good, which category is performing bad, and based on that they try to take a business decision. Again, I'm not saying that it's just a mode, I'm just trying to build a context that this is one of the factor, right? So I'm just trying to say that this is one of the factor. I'm not saying that just based on the mean median mode you will be able to perform all kind of operations inside the data set. Practically that is not possible. Otherwise we would have concluded our class just with the mean median and mode in statistics. But no, that is not going to be a reality at all. Okay, so yeah, so wherever we have a categorical data distribution, we have to find out the frequencies. Obviously we'll try to go ahead with the mode. So again, this kind of a application you will be able to find out into a retail, into a education, into a marketing, into a e-commerce, nowadays into a quick commerce, or even your fleets. You will be able to find out this kind of applications everywhere. So practically it's been used in each and every application in terms of doing a data analysis. Now here, are you able to understand it, guys? And I think we are not making this class boring, right? Everyone, are you feeling like bored? Hope you are able to enjoy the conversation, you are able to enjoy the discussion. Yes, everyone. अच्छा, आज यूट्यूब पर लाइव है यार, यहाँ तो कमेंट देखना. आई जस्ट फॉरगॉट टू सी द लुक इनटू द कमेंट व्हिच आई एम गेटिंग फ्रॉम यूट्यूब. I'm just focusing on a comment which I am like a conversation which is going inside the class. Okay, fine, leave it. Not bored, but some difficulty to understand. Okay, Teddy, not an issue. So with time, I'll make it easy, and even you will feel like easy this entire things. Okay, fine. Now moving ahead. So mean median mode is completely fine. Now moving to the next one. So here we have listed down two things. So measure of central tendency and measure of dispersion, right? So measure of dispersion. Now what and all things comes inside the measure of dispersion? Let's try to understand that particular part. So here again there are three things comes into a picture inside a measure of. So measure of dispersion. There are three things comes inside this particular part inside measure of dispersion. Anyone give me all those like a three things which comes inside a measure of dispersion? Yes, anyone? I think someone told me in the beginning itself. I saw that in the chat. Yeah. Anyone? Okay, so Ibrahim is saying variance true, STD true. Sri is saying STD. Third one, standard deviation basically. STD means, yeah, standard deviation. So variance, standard deviation. So what is the third one? By the way, there are three actually. So Joy is saying range, variance, and standard deviation. Correct. Yes. So under this measure of dispersion, there are three things comes into a picture. The very first part is basically a range. The second part is basically a variance, and the third part which you are going to encounter is a standard deviation. So these are the three things that all of you are going to encounter under measure of dispersion. Now let's try to talk about these three things one by one, one by one, with the respect to examples. That what is the meaning of range, where we can try to use it, what is the advantage, what is the disadvantage, what is the meaning of variance. I believe most of us are aware about variance and a standard deviation, but maybe we are not able to recall it, and we are going to recall it over here, right? We are going to recall it over here. So basically, what is this measure of dispersion? So measure of dispersion is basically nothing but a statistical fundamentals or statistical tool, you can say, so which always try to describe the spread, right? Disperse means what? The spreadness. Yeah. So these are the tool, or these are the fundamentals, so which is going to define or describe the spread of the data set or variability inside a data set. Now, what is the meaning of it when I say these are the term which is going to define a spread inside the data set or variability of a data set? So, what is the actual meaning of this one? Let's try to understand. So, the very first part is basically a range, right? So, very first part is basically a range. Now, what is basically a range? Anyone, guys? So how we can define the range? So let's suppose I have a data, something like 1, 2, 5, 8, 8, 10, and 12. Now, what is the like a range for this particular data, guys? I believe just by looking into the data, you can tell me, right? That what is the range of this particular data? Yep. So range is nothing but the max value that you have. So what is your max value? Max value is equal to 12. And what is your minimum value inside the data? 1. So basically 12 minus 1. So that is going to be your range. Or 12 to 1, 1 to 12, we can say that my range of this data is basically 1 to 12, right? Now, even in day-to-day life, so we try to use this term very frequently. So, what is the cost of living for anyone inside a Bangalore city, inside Delhi, Noida, or maybe Chennai, Hyderabad, Gurgaon, or somewhere, right? So, whenever someone asks us this question, that what is the cost of living? So, we always try to say in terms of a range that, okay, so maybe between this range to this range, it is going to cost you. Again, so whenever we try to ask a question that what kind of a laptop I'm supposed to buy, how it is going to like how much it is going to cost me. So in general, so people are going to give you advice that if you're going ahead with i5, then this is the range. If you're going ahead with i7, then this is the range. If you're going with i9, then this is the particular range in which you can try to look after. Again, same thing happens with every kind of a purchases, that whenever we try to make some sort of a estimation, so we always make sure that okay, we try to make an estimation based on the range of the values. Now, if I'm going to ask you a question that what will be the temperature in Delhi in a winter season, so you're not going to tell me that temperature is going to be 15 degree or maybe like a 12 degree, something like that. No, you are going to give me a range that temperature will be in a daytime, temperature will be somewhere between uh, maybe 15 to 25 degree, and then in a night, so it will be between somewhere 10 to 15 degrees, something like that. This kind of analogy you are going to give me, and based on that you are going to give me my answer, right? So again, range is something which we try to use it on a regular basis, and based on that, we try to do a lots and lots of conclusion. We try to do a lots of derivation of a data set. Simple, right? So here, if I'm going to ask you what is a range, so it's simply 12 minus 1 is equal to 11. So 11 is basically a range. So my data is varying between 1 to 12. So my data is ranging between 1 to 12. This is something that you will be able to find out. Now, what is basically a meaning of second term, which is basically a variance? So anyone, guys, any idea what is the meaning of variance? Yes. What is the meaning of variance? Spreadness of the data is variance. Okay, fine. Anyone else? A spread of the data. Yeah, that's fine. Joe is saying population. I'm like, no, not at all. I'm like, population? Why are you talking about population? Okay, maybe you're talking about population in some different context, but yeah. So let's talk about our variance, guys, over here. Variance. So variance is nothing but a spread of the data point in a formal term, if I'll say. And now, what is the meaning of this spread of the data point, and how we are going to calculate a variance or anything? So again, variance wise, so you will be able to calculate two kind of variance. One is a population variance, and one is a sample variances. Now, this is a notation for a variances. So this is a notation for the variances, and this is something called as population variance. So this is something called as population variance for population whenever you are going to calculate. So population variance and sample variance is not very different, but yeah, there is a minor differentiation you will be able to find out between a population variance and a sample variance. Now here, so this one is nothing but population variance is nothing but summation of I is equals to 1 till I would say n, and then data minus its average. So population average is called as mu and sample average is called as x bar. So here average divided by n. So this is a equation for calculating a variances. So how many of you were able to remember this equation in childhood, guys? I think in a childhood, many of us used to do a like by heart this equation, right? In our childhood, so many of us used to by heart this equation. So how many of you have done that? Yep. Okay, many of us, I would say, right? Many of us has done like this by hearted this entire equation. But if you will just look into this equation carefully, it's nothing. Basically, it's nothing, right? So it's something like data minus, so xi minus its average square divided by the total number of the data set which is available to you. So for example, if I have to calculate a variance, so let's suppose I have a data set. So maybe I have a data set 1, then 2, then 4, then 5, and then 3. So this is the data set that I have. And someone is asking me, this is the population set, let's assume. And someone is asking me that try to calculate a variance. Okay, simple. So first of all, I have to calculate what? So I have to calculate a mu, means basically an average of the data. Population average is called as mu, denoted by mu. So here, what I will do is I'll try to calculate the average of it. So what is the average? So 2 plus 1, 3, 3 plus 4, 7, 7 plus 5, 12, 12 plus 3 is equals to 15. 15 divided by 5 is equals to 3. So mu is equal to what? 3. Average is equal to what? 3. Okay. Now if I have to calculate the variance, what I will do? So 1 minus 3 square plus 2 minus 3 square, 2 minus 3 square plus 4 minus 3 square plus 5 minus 3 square plus 3 minus square plus 3 square divided by total number of data, which is 5, right? 5. So what will be the result? 1 minus 3, 2. So 2 of a square, 4 plus 2 minus 3 1, 1 of a square 1, 4 minus 3 1, 1 of a square 1, 5 minus 3 2, 2 of a square 4, 3 minus 3 0, so 0 of a square 0, divided by 5 is equals to 4 4 8, and 2 10, divided by 5 is equals to 2. So your variance is going to be 2 over here. Simple. You're not supposed to buy heart anything. Literally, you don't have to buy heart not even a single piece of it. It's very simple. Data, this is the data, right? Data minus average square divided by total number of data. This is what it means. Simple, right? So data minus average divided by for population. So if someone is telling you that it's a population, right? It's a population. Raghavendra is saying that standard deviation is square root of variances. Yes, that's true. SQRT of basically this one is going to be a standard deviation. Again, for a population, for a like a sample, it's going to be different. Now, let's suppose if I'm supposed to calculate a variance for a sample. This is variance for the population. If I have to calculate variance for the sample, so this is the formula. So it's denoted by S for sample. This is for population. This is for sample variance. Notation wise it's different, but again technically it's same. We are talking about just our variances. Now here, so summation of I is equal to 1 till small n we used to write, just a notation I would say. Then data minus average. So sample average is denoted by x bar square divided by n minus 1. So we try to write n minus 1 in denominator because of error collection. So after many experimentation, people have found out that whenever we are talking about a sample and to correct a error inside us, and there is a research paper on that, actually, you will be able to find out that why people used to write n minus 1 in a denominator in case of a sample, whereas in case of a population, it's just number of data, which is technically just n, right? But here in case of a sample, so if you are go ahead with the Google and search for it, and even on Wikipedia you will be able to find out the complete article about it, that there was a error correction that people were looking for, and they have observed after doing a multiple experimentation that whenever we have a sample data in a denominator, never try to take n. So if you are looking for an accurate and exact result, in that case always try to consider n minus 1, and then it is going to give you the correct result. And based on that experimentation, they have fixed this particular formula. That okay? But technically it's n for a population. So if you have a whole set of a data, it's just n. Otherwise, in case of a sample, you have to use n minus 1. Making sense to all of us, guys? Yes? Okay. So calculation wise, it's nothing. Anyone and everyone will be able to calculate this entire variance things. Okay. Now let's talk about the application of the variances. So any idea, guys, where we can use like a variance application wise? Any idea? Anyone? So where we can go ahead and use it like a okay. So we can use a variance and then like let's try to conclude something on top of it. Yep. Anyone? To check if the data has a skewness again. So it's not like you have to look for so see, there could be an extreme skewness. Now over there anyhow you will be having a different tools and mechanism by which you will be able to find out. I'm talking about the small one, even a small changes, right? It's basically a square. So let's suppose I'm trying to manufacture boxes, right? I'm trying to manufacture a boxes, maybe I'm trying to manufacture a bottles or something like that. I'm trying to manufacture, and I have a manufacturing line. So in a lot we try to build a product. In a lot, basically a batch number 1, batch number 2, batch number 3. So in a lot, particular lots, we try to build a products. Now so over there obviously we need a matrices by which we will be able to measure even a small variances, right? Even a small variances inside my entire product, or between a different kind of a batches, or maybe We can like a manufacturing plant is one of the use cases. Then in terms of a risk assessment, right? So measuring a stock price volatility, that how much stock is going to fluctuate from the average or from its middle point. So everywhere we are going to use our variances. As its name suggests, it always try to give you a dispersion into a data set at any point of a time. So wherever you are looking for such kind of a things, yes, you can use it. Skewness is an obvious case, right? Skewness is an obvious case at any point of a time. So again, in terms of a real-time data analysis, if I'll say, so it always try to help you out in terms of a spread of the data, like a income data, maybe a taxation data, or anything like that. So wherever you are looking for some sort of a dispersion, that how much it is dispersing from the actual like a range, you can go and happily try to use basically our variances. So yes, easy to compute, easy to interpret. Now coming to the next one, which is a standard deviation. Now what is this standard deviation, by the way? So standard deviation is nothing but standard deviation is nothing but anyone, guys? I believe we all have studied a standard deviation in our childhood, right? Raghavendra is saying a standard deviation is a measure of how much individual data point in a set deviates from the average value, showing the amount of variation or a spread of the data. Yeah, that's true. That's true. Okay, so standard deviation. Now, what is the meaning of a standard deviation? So basically, standard deviation always tells you that what is the amount of variation or dispersion into a data set. Amount of variation, this is what you all will be able to get out of this standard deviation. Now in case of variances, I would say, so it always try to indicate that how far each data point is from the mean. So the difference between variances and a standard deviation is variance always try to indicate that how far each data point is from a mean, which is average point, basically from the mean point, basically, right? And in that way you will be able to find out insights about the variability of the data set at the end of the day. So those who are getting confused, and again standard deviation and variance confuses a lot, right? So variance is nothing but it's an indication of each and every data set how far they are from the average. This is what variance is going to define. And now if I'll talk about a standard deviation, right? If I'll talk about the standard deviation, so it actually quantifies means it gives you the exact number. Simple. It gives you the exact number. It quantifies the amount of variations. Making sense, guys? A difference between these two, standard deviation and variations. Yes. So if I talk about a standard deviation, so a standard deviation for the population is nothing but, right? So standard deviation of population is nothing but just do a square root, you will be able to find out a standard deviation for a population, and just do a square root over here and you will be able to find out a standard deviation of a sample. Simple. So it's the same thing, but yeah, so we are trying to find out the square root of it. So here if I'll talk about a standard deviation of a population, so you can try to denote it in this way, and it's nothing but summation of I is equal to 1 till n x of I minus mu is square divided by a capital N. Now if I'll talk about a standard deviation of a sample, so in that case it is going to be summation of I is equals to 1 till a small n xi minus x bar square divided by small n minus 1. Simple. So this is basically a standard deviation at the end of the day. So it always tells you, it always quantifies, basically standard deviation always try to quantifies that how distant a particular data set is from a mean. Now So let's try to understand with the help of previous example itself. Now here, what is the standard deviation? So what is the variances? So variances is basically 2. Now if I have to find out the standard deviation, what will the standard deviation, guys? Root of 2? Yes. What is the standard deviation? Can I say root of 2? Yes, everyone. It's root of 2, right? Now what is the root of 2, by the way? What is the value of root of 2? Yeah. Someone is saying 0.414. I think it's a 1 point. You like forgot to mention 1 over there. So it's going to be 1.41, right? It's going to be 1.414 if I talk about a standard deviation. Okay, fine. So we had a data set 1, 2, 4, 5, 3. This is the data set that we had. Now mu is equal to this. And then if I'll talk about a variances, so variances was 2. And if I'll talk about a standard deviation, so which is this, so I'm considering that this is the population. This is a population for me. So a standard deviation is 1.414. Okay, that's great. Now here, so what is a range of the data? So data is ranging between 1 to 5. Now what is the average? So average is basically 3. Now just try to observe over here. So average, just with this small data set, I would like to show you. So average is actually 3, right? Data is ranging between 1 to 5. Now till one standard deviation, let's suppose this is the one standard deviation on both hand side. So till one standard deviation on left hand side of this mean, which is the average is what, 3. So on a left hand side of this one standard deviation, on a right hand side of one standard deviation, how much data you will be able to cover? So 3, right? So 3 plus 1.414. So this point is going to be 4.414. And this point, this side of the point is going to be approximately 1.6 something, right? 1.59 or 1.6, this point is going to be. So here my data set was ranging between 1 to 5. So can I say that most of my data set will come under this, within one standard deviation on left and right? Yes. So means even if my data is going to deviate, so maybe most of my data set will come under one standard deviation. Then there is a concept of two standard deviation, which I'm going to explain you in a normalization curve. So two standard deviation. Now if I'll talk about a two standard deviation, so what will be this point? So 1.6 again beyond it. So 1.6 minus 1.4, which is going to be zero point 0.2, and then 4.4, and then 1.4 once again. So this is going to be 5.8. Can I say that within two standard deviation I'm able to cover 100% of my data range? Yes, within 100%, like I'm able to cover within this data range. Yep. So going forward, I'm going to talk about a standard deviation a lot when I'm going to talk about a normalization curve. And what is the meaning of this one standard deviation? What is the meaning of a two standard deviation? What is the meaning of a three standard deviation? Actually, there is something called a three standard deviation, where you will be able to cover 100% of the data, right? 100% of the data. And then you will be able to define a skewness. You will be able to find out the outliers in a easiest possible way. And that is something which I'm going to discuss in my normalization curve. And in upcoming classes, I think maybe tomorrow, depends upon the syllabus and chapters. So maybe tomorrow or maybe in a next to next class. So I'm going to talk about it. And I'm going to talk about even again what is the meaning of 1, 2, and 3, and why I'm even talking about it. And generally people think that it's just one standard deviation, right? Many people don't even think about like a two standard deviation or maybe a three standard deviation that exists. And then you will be able to understand exactly that what is a standard deviation. So when I'm saying that it's basically a measure or exact measure of a data from a mean on left hand side or maybe on a left hand right hand side. So how standard deviation is going to play a crucial role over there. Making sense, guys? Yes. So Raghavendra has mentioned 66.7% data. Yeah, that is something which I'm going to discuss, Raghavendra. So what is the percentage of the data which comes between one standard deviation, then two standard deviation, and then three standard deviation? So anything falling lesser than three minus three standard, we can call it as an outlier. Yes. Okay. So someone is asking me a question that what does variance is equal to 2 indicates in the data set. So Mansi is asking me a question that what is the indication that like we have a 2 over there, right? So what is a meaning? What is a meaning that like what is the meaning of this particular 2? Mansi, just look into the data, look into the mean, right? And then 3 plus 2 and 3 minus 2. You will be able to get your answer. Your entire data set is ranging between that range. Yes. So it's basically giving you a spread of the data point. So it is just trying to indicate you that how each like a data point can go, like how far each and every data point can go from a average. Yeah. Okay. Okay. So fine, guys. I think it's a time now, and let me. Shall I share this one in a, or shall I leave it? Like maybe I can share it tomorrow. Yeah. So I'll share this entire slide maybe by tomorrow. Or there is nothing inside this one. I have just written a couple of things, and I believe you are like you have already taken a note of this one. How is Euron answering the question in a chat? Yeah. So it's an amazing system that we have deployed. It's actual use case of data, like a data science. Because of that, Euron is answering a question inside the data set. Okay, fine, everyone. So I believe we are good for today, and hope all of you have enjoyed this particular session. Those who are sitting on YouTube or other social media platforms, hope all of you are enjoying it. And yeah, so today we have made this class live, public for all of us. Tomorrow it is not going to be public for any one of us. So obviously it is going to be the class just inside the dashboard. So thank you so much, everyone. Thank you so much. We will keep on bringing a lot of features. So just go and check your own dashboard. So you will be able to find out some of the amazing feature inside the partners with dashboard. And even in future, so we'll keep on bringing a lot of features. And we have released one page in a header. Sorry, in a footer, you will be able to find out. So where we are talking about all the upcoming release, which is something called as change log. So if you'll go over there, you will be able to find out that what we are releasing in January month, what we are releasing in February month, tech wise, not a course wise, tech wise. So yeah, hope all of you are going to enjoy this platform. And thank you so much, everyone, for joining the session. See you again in my tomorrow's class. Thanks, everyone. Thank you.